Hello.
Yeah, can you hear me?
Balu, clear?
Yeah, yes, sir.
Yeah. So, what about other login? Is it ready now?
Yeah,
Login,
it's
other
ready.
login.
I'm logging in now.
Check it.
Yeah. Sir, can you see my other login?
Just a minute. Hari Prasad?
Yes, sir. Given, sir.
Is that other login is ready now?
Yes, sir. Ready, sir. Both login are ready, sir.
Okay. Shall we start? Balu?
Yeah, yes, sir. Sure.
Yeah. Hari Prasad?
Yes, sir. We can start, sir.
Yeah. Good afternoon, everyone. I'm very happy to introduce Mr. Balasubramaniam, who is graduated from Department of ECE from Adi Shankara College of Engineering Technology in the year 2009. He's like all the students who are all participating here in the year 2009, but he's not like that now. He has he has reached to a very high level, and he's now working in one of the company called AIB Ireland in the area of Devops. And I requested him to deliver a talk on his own choice, and he accepted, and he's now ready to deliver his talk. And he is proven as the best alumni from the Department of ECE. I am very much privileged to make this his association here now with all the students of Adi Shankara. And I invite all the participants from Adi Shankara College of Engineering Technology and other colleges, faculty, students. So I don't want to take much time. And once again, I invite Mr. Balasubramaniam to address all the participants. Will you? Balu?
Yeah, sure, sir. Thank you so much.
Yeah, please carry.
Yeah, hi all. Very good morning. And my name is Balasubramaniam Mekala. And yeah, I'm 2005, 2009 passed out of engineering, Adi Shankara College of Engineering and Technology. And I'm happy to be here. And I'm very thankful to Dhanisa for giving me this opportunity. And yeah, I would like to start the session if you're okay, so that I will actually take you through my journey and everything, like what and all we did, and how we have gone out of Adi Shankara, and the hurdles we have faced, and how the college has helped us really. And we're going to I'm going to take through everything. And I would also let you know that though the title is just Evolution of IT from Waterfall to Agile to Devops, I'm going to discuss a lot about your life and how the Agile process is going to help you in your even personal life, and how you are going to, how the technology is going to evolve, and how your personal life is going to evolve, and your interview preparation and everything. So mostly I'm going to cover everything. So can I start the session, sir?
Yeah, please carry.
So I'm just going to unmute my video. Let's stop the video. So yeah. Yeah, my webinar is going to, I have divided webinar into 4 or 5 parts basically. So the first part is going to be introduction, and yeah, I think we have done with the introduction 5 minutes. So I'm going to start with the psychology part. And don't think that why we are actually talking about all these topics, though the title is not relevant, because I'm going to connect each and every dot. And please give your focus and attention for next 1 hour, so that I think this session is going to be your life-changing session if you really focus and attend. And I'm going to talk about how the psychology works, and how we have to do it in your life, and how the DevOps is actually evolved, and how your job and resume tips and Q&A. And I don't want the session to be a complete dry session where I'm just going to talk about all the stuff which you're not interested or something like that, because each and every word or what I'm going to talk is going to be very helpful. So please give your complete attention to the session for next 1 hour. So let's start the session. So yeah, as I already mentioned, I'm a passed out of 2008 and 2009 And I would like to start the session like this, like how did we handle the last crisis? Because after 2008 2009 crisis, the next crisis is like the 2020 COVID crisis. So the batch who are coming out from the 2020, they are very similar to the batch, the 2008 2009 batch, passed out batch. So I would like to take you through what and all we have gone through. Like the moment we are gone out of in 2008, all our seniors got 2 or 3 jobs in Ashankara. Like they got TCS, Infosys, multiple jobs each guys. So when we got like 2009, we got very limited jobs because there was no much openings outside, and even if you got, there are no much openings. So as everyone, like we were not aware of that, and that was first time like we have seen such major crisis. Then how did we handle it? What did we learn from it? Everything I'm going to take you through. So that's initially this is what we thought, like once we are passed out of the college, we thought this is how our life or our path will be, because until college everything will be so smooth. You have lecturers, you have HOD sir, and you have everyone to take care of you, and you have all the path guidelines. But once you come out of the college, this is how your life will be, because you really don't know what you're going through, and you really don't know, and you cannot apply what and all you have learned everywhere. So every situation will be different, and in every situation, every skill set and everything is going to be different. So when it is so different, when the world is so uncertain, how can we deal with it? So when the world is so uncertain, so basically what I'm trying to do is I'm trying to give a basically template kind of thing for you. It's kind of a framework, and if you try to apply the rules and the strategies what I'm going to discuss today, 80 to 90% of the problems can be resolved, and few remaining 10 or 20% which are not in your control, and it's anyway we cannot do anything with them, just pass on. Then remember these guys, your decision is your destiny. When you passed out of the college, it's a school, then you look at 10th class, then you might have taken a major decision whether you want to go to MPC, BPC or CEC, whatever. Then most of the guys took MPC, then they have come to, I mean, I'm just, as I'm representing engineering here, graduates here. So most of the guys, then they get into intermediate, and after that they'll take whether it's engineering or a degree or whatever. Then again you will have a choice, and then you will get into engineering. And if you look at the most of the things, what I'm actually trying to show is, in life, if you look at basically 1, 2, 3, 4, 5 maximum. So your life is actually consists of only 4 decisions that you have taken so far. Out of your entire, like out of your 21 years, you have taken only 4 major decisions in your entire life. And from here, if you look at, you might be wondering what these are. From here to here, all your life is same, including with your friends. And from here, everyone's life is going to change. So every decision is going to take you somewhere. So be cautious. And as I'm saying, every decision, it has to be like, you have to be a conscious decision maker. That decision, what you're taking, few may go with heart, few may go with brain, but this is the area where you have to be. You have to be wise, my friends. You have to take both, where you have to consider both your past experience, research, logic, statistics, and then you have to go with your emotions as well. You have to go with your feelings. You have to go with the sadness, anxiety. You have to take care of everything. I can tell you a simple example, like you cannot directly go with if your financial status and if your family status is not good, and you cannot directly go to movies and you can spend some 15-20 years there, because you cannot afford that right now. So there will be different path for everyone. We cannot apply the same logic to everyone. So what I'm trying to say is, this is the area you have to be, and every new decision is new life, as I already mentioned. So as you have spent only 4 major decisions so far, so I'm just trying to give a few principles where you can apply. So most of the times you might have heard the term called smart work. So I would like to give this is called Pareto principle, where if you consider this 100% of your life, or if you consider anything, 20% of the input or time, resource, effort, or anything accounts for 80% of the output. You might be reading only 20% of your entire semester, but you might be getting like 70% or 80% of the result. But even in exams, till 70 to 80%, you can go through, you can get easily. But from there, for every 1 mark, it is going to be so hard. So that is the reason. What I'm trying to say is, you no need to get 100 out of 100 anywhere. You just need to get, but you have to get like 65, 60, 75, 80, around that. And from there, utilize only 20% of your effort and save your 80% to something else. You should have all-round development. You should not be only technology enthusiast. You should have awareness on finance. You should have awareness on economics. You should have awareness on politics. So you should be like all-round. You should have all-round development. Then only your decision making will be so good. And once you apply that, then work hard on that 20%, whatever you have selected. So whatever the effort you are putting, you have to put so hard. What I'm trying to say is, if you have 100% of time, then put the work hard in that 20% of the thing which you have selected. Then advertise. Whatever the work you are doing, you have to let the world know. The situations are completely different now. Because of the growing population, because of the growing competition and growing demand, everything is demand and supply here. So because of that, no one is actually give attention to you until you advertise yourself. This is very, very important in career. If you are an entrepreneur, or if you are a job seeker, or if you are anyone, you have to do that. I can say this is a simple formula of success. So most of the people, like whatever you are focusing so far is only on this one. Your marks, your score, everything is only 20%. The remaining 80% is mindset. Your mindset decides where you are going to be, not your marks, not your score, not your college, or not your anything. They are all going to support you only further growth. Definitely college is very useful. Your score is very useful. But that only accounts 20% of your growth. The 80% you need to cultivate the mindset. What kind of mindset do you have? There are basically two mindsets. One is growth mindset and the other one is fixed mindset. Growth mindset is something like it's open. They're like continuous learners, and they don't get frustrated soon, and they have a lot of patience. And even if they fail, they'll try to find the path to succeed. And their effort and determination, their effort and attitude determine everything. But if you look at fixed mindset people, they cannot take negative things. They don't like to be challenged. They don't want to fail. A lot of insecurities, basically. They will have a lot of insecurities. So most of the things you have to be sitting under growth mindset. So right now, if you might be thinking that you are not growth mindset, you are somewhere around fixed mindset, don't worry, guys, because we try to do whatever we believe we are. In simple sense, we have defined ourselves that I'm so-and-so, I'm really good guy, I'm a bad guy, I'm an arrogant guy, or whatever. So we have actually, we have defined ourselves sometime back, and you can redefine yourself. You can redefine yourself and you can raise your standard. The moment you raise your standard, you can redefine yourself. How do you redefine? It is something like, even whatever the small choices, consistency plus time equal to radical difference. What does it mean? It is nothing but, yeah, it's nothing but, if you want to do something, you need to cultivate new habits. New habits is nothing but, then you need to make it you need to be consistent with the habit, and over time you will get a major differences. Something like your choices, it's nothing but your habits. that will convert. Sorry, it's nothing but your like what you want to change. That's a choice, and then that will cultivate into your behavior, and that behavior will convert into habit. That habit will convert. That's nothing but they call it as a ritual, like what you do every day. If you're doing something every day, like if you're doing brushing every day, you don't feel it like a work. You don't actually think that you're doing brushing every day. You don't even consider that as a work because it's a habit. You eat meals 3 times a day. You don't consider that's a habit and a need as well. So you need to, if you want to achieve something, you need to convert everything into a habit and a need, because you need to convert into must. Then only we actually make it into bigger things. And the simple things every day, like if you read 1 hour per day, after 365 days, it will become 365 hours of effort. So every small thing, like you might have learned something in school as well, like compound interest. It is something exactly applying the compound interest for our day-to-day life that actually enhance everything, like your success, income, relationship, health, everything, even workouts. If you do 1 hour workout every day, after 1 year, you'll be so fit. So once now we have talked about like how to rise our standards and what are all the hurdles we have faced, and basically like what are all the now how to achieve the goals. Basically, this is a simple formula. The simple formula is something like you have set up your goals. Setting up goals is nothing but you have raised your standards, and once you have raised your standards, to raise your standards, basically you should have a clear vision. Basically you should know where you are going after the job, or like whether you want to go to job or whether you have to follow your passion or whatever. It should actually, that will convert into a goal. Once you set up the goal, for every goal you will get a problems. Definitely, like most of the times you'll get a problems. Once you get a problem, then you have to diagnose what's the problem and how you can fix that. Then you can design a solution for it. Then you can actually go forward. This is the practical life. Your life won't be like a straight line. It will be something like this. You will have these bumps every now and then. So overall, this is how your life will be like. You'll get a problem, you will correct it and you will move on. You'll get a problem, correct it and move on. Problem, correct it and move on. Sometimes you may feel low, you may feel stressed. You may think that this is the end of the world, but nothing will happen. Everything will be positive, because maybe you might be at this curve, you might be at this curve. So you are just at one of the curve, but you will find out and you will go and you will move on. And you should know your exit as well. Like if few things may not work and you have to leave it. Whenever you are trying to take a new business or new job or new whatever, so you should know your entry and exit at the same time. Entry and exit. What does I mean by entry and exit? If you're actually getting into a business with some 10 lakhs, and you should know that if I get 2 lakhs loss, I'm out of the business. So you should not actually, or you should have a limit where you can actually bear the particular loss, and you should have that limit, and you should have that exit strategy as well. Then only you can survive. This is something called risk management. In life, for every bump, if you want to actually achieve, then you should have a risk management. So it's nothing but what I'm trying to say is like progress is happiness. So the moment, if you look at the overall progress, it's nothing but, yeah, if you look at it, it's nothing but overall you are actually progressing. So the key takeaways of this, it's nothing but raise your standards, constantly redefine yourself. You can actually redefine, then you can actually raise your standards, then have a clear vision, the clear goals. If you know your target, then only you can drive. If you are a driver of a truck or something, a bus, if you don't know your target, where you are going, you cannot go anywhere. And whatever the hard work you do, it is absolutely useless. Without a clear vision, without a clear goal, how much ever the work you do, it's absolutely useless. So you should have clear vision. Then that should be actually do with hard work. Then it is very good. Then be passionate. So what do I mean by push or pull is something like, if you are actually looking for something and you need to push yourself, and if you need to rise, and if you need to work hard, it doesn't go so long. You cannot push yourself for so long. Your goal should pull you. That itself will pull you from that. You no need to push yourself. You have to wake up, and that your goal, which it should, that itself should pull you. So you should be that passionate. So know your passion and be passionate about that, and constantly improve. It should be like a continuous improvement, and stay hungry. Even if you get a job, even if you get a promotion, even if you get an onsite, even if you get a, like, even if you become an entrepreneur, and if you are successful, stay hungry. Be constant learner. Then, as I said, have a clear entry and exit before taking any major decision. And leverage the power of compounding effect. As I mentioned, what's the compounding effect? Leverage the power of compounding effect. Then this is the most important. Don't overestimate what we can do in 1 year, and don't underestimate what we can do in 10 years, because humans are actually tend to overestimate what we can do in short term and underestimate what we can do in long term. So have a clear long-term vision. So these are the basic key principles. Then let's move on to our waterfall. So the waterfall is like, basically, so far I have just discussed the principles of the psychology and everything, and the principles, whatever I have discussed, everything is from Agile, and everything is, it's not directly from Agile, but the basic root is from Agile. So now we are moving to waterfall. What's a waterfall or faith-based model? Waterfall is nothing but when you have a code or something, when you have a product, and when you have, suppose if you take any Android mobile or anything, then you will actually get a client from client, then you will actually get a requirement, then you prepare a use case of that. So that's like gathering requirements. Then you will actually design. Then once you design, who will design that? Then the requirements will be gathered by business analyst team, and design will be done by architect team. Once that is done, the implementation or the coding will be done by development team, and the verification will be done by QA team, and maintenance will be done by operations team. So basically we have 1, 2, 3, 4, 5, basically 5 teams, and everyone will be managed by management team. So overall 6 or 7 teams. So it's basically like, and we do one by one, like after requirements we do design, after design we do implementation, after implementation we do, and it's a sequence, it's a sequential process. It's something like the name indicates, waterfall. It is like a top-down approach. So this was the traditional approach what they were following. Later they moved to Agile. Why did we move to Agile? Because we thought that's too long, and if it is taking 3 months of time, the entire process, they want to do 1, 2, 3, 4, 5, 6, 7. They want to do 6 or 7 times the same thing, because they don't want to make it complex. They want to, they are trying to divide everything in smaller pieces, so that actually they can actually take the feedback and actually do the another part. Because if you look at the waterfall, there is no feedback. If this process takes 3 months, until 3 months, until the maintenance comes, if there is some issue or bug comes up, again it goes to here to requirements. So they have to follow again 3 months time. Again, after 3 months, if they find the issue again, they have to go 3 months. So to correct the issue, to come to the live, it takes 6 months. So that is the reason they divided everything into small pieces in Agile. That's how they have come up with the Agile model. Then again, they do the same thing, like a design, development, test, validate, deliver, everything. But it looks same, but this is how the basic difference will be. Like, they do the requirements, design, everything in 3 months, and they hit one big outcome at end. But in Agile, it's something like they divide everything, as I said, small pieces, like those small, like they call it as sprints. So your requirements, design, development, testing. So this is one small print, and they have delivered one small target. If you look at it, they have delivered a small, which is useful, which should be useful for a customer. And again, they did the second sprint. They did something bigger. It's a cumulative outcome. And they did something again. They did a bigger outcome. So that's the basic difference of Agile and Waterfall. To understand it better, so the basic Waterfall is something like, this is if they want to design a car, this is how the requirement is. Basically, client wants to move from like GUDUR to Nellore. So then in waterfall model, they designed a tire first, then they have designed this one 2 tires, then they have designed a half frame, then they have designed a full car. So until they design a full car, client cannot use it anywhere in between, because it's a completely until at end they cannot use it. But if you look at this one, this is something like, first you give something like a skating, so that he, instead of walking, he can move faster. Then you have given something like a bike, then you have given a cycle, then you have given a motorbike. Then, so if you look at this closely, every stage it's a working model, but it's not fully functional. Sorry, it's fully functional, but it's not up to the mark. Like, we can improve, we can constantly improve, but at the end the client is fully happy, but he can actually use it even in intermediate results. That's the basic philosophy of Agile. So this is basically the Agile or lean thinking. So if you look at Agile or lean thinking, like the roots are like system thinking, adaptive system complex, then psychology, queuing theory. Then the lean or Agile is like the branch, but Agile can be implemented with Scrum, extreme programming, Kanban. So it can be implemented with multiple ways. So if you really look at it, basically everyone will not use everything. Most of the people they are using Scrum. So mostly you will be working at this branch most of the times. So because, and you need to understand all these psychology, adaptive thinking, system thinking, so that then only you will understand what you are doing actually in the Scrum. Don't worry guys, I'm going to take you through everything, so that you don't understand like what is daily Scrum, what is product backlog. I'm going to take you through everything, but on a high level, for visualization purpose, this is what the Agile is. Then what's the Scrum methodology? Like the Scrum methodology will have basically the Scrum team will have in traditional waterfall, you will have a business owner, then they will have a project manager, then they will have a team leader, then they will have a team members. But if you look at Agile, your team will be different. Your team will be like, you will not have any team leader, you will have a Scrum team, and you will not have, and you will have like a Scrum master and a product owner and a stakeholders. I will actually come to this slide after this one. Like the team structure will be like, even before waterfall, it was like a development team, a BA team, a tester team, a DBA team. As I showed in previous slide, in waterfall, every team is responsible for each phase. But if you look at the Agile, everything is called a Scrum team. There is no development team, BA team, tester team, everything. But if you look closely, the colors in each one, they have picked one from development, they have picked one from testing, they have picked one from, so they have formed a team, and each team is capable of doing everything. So that's what the basic Scrum team. The philosophy is like every Scrum team should be capable of doing everything. And apart from that, as I showed, they have removed project manager and they have come up with a Scrum master. What do they do? Like basically the team structure is something like this. Suppose if he's a project manager and this is the team, most of the times in traditional waterfall, the project manager used to discuss, he used to be like a boss, and he used to take care of the team. But in Scrum Master, if you look at it, there is no one like a boss. Everyone is same. This is lateral. And even Scrum Master is not a boss. He's like a servant leader. It is like he's being as a servant, he'll become like a leader. Like he will show the leadership qualities. And so the basic psychology is like, when someone is actually bossing on you, you really don't like to work in that environment. So that is the reason where the Agile has corrected that, and they have come up with a Scrum Master. So that you do, and if there are like a team leader and a team member, and if there are different hierarchy, then you will have a lot of dependency. If you're a team member, you have a lot of dependency on your team leader, and your team leader will have a lot of dependency on project manager, and your project manager will become the bottleneck. Team. So as I said, cross-functional is nothing but they picked everyone from each department, So, and everyone is actually expected to do everything. And basically these are the high level differences. Like project manager owns the project man, but here product owner represents the business, as I mentioned. So product owner is actually responsible with the business and the stakeholders, and the scrum master is responsible for your scrum team. So responsible in the sense he doesn't own any delivery like a project manager. It's a completely responsible for of a scrum team member. So, but he actually tries to remove any impediments in the team. Impediments is nothing but any problems that you are facing. If you have any, if you're looking for any issues, he will take care of it. So on high level, this is how it is. Like basically, how do we do the daily, like day-to-day activities? Like in Waterfall, you get a requirement and you actually do it, and weekly once there will be one meeting, and then we do deliver it, and then we'll have a delivery call, and yeah, that's it. Mostly there won't be much collaboration or interaction with the people. So most of the people, they work in silos. But the basic philosophy of the Scrum is nothing but people has to interact every now and then. So if you look at like there, actually the pillars is like transparency, inspection, adoption. It's nothing but, I mean, I don't want to talk terms, so that I just explain, like it is something like people has to interact with each other every day, and on top of that you should actually collaborate. So in here, this is called a product backlog. Product backlog is like if you're working on a product, if you're working on some Android product, or if you're working on some mobile product, whatever. So you will actually divide all your tasks into tasks. So you will divide everything like this, and then that will actually get into sprint planning. As I said, every curve is called a sprint. So we are in, I'm just explaining one of the curve that. So we get into sprint planning, and out of these we actually select only 3 or 4 in that, because based on every sprint will be basically 3 weeks, 2 weeks, like sprint will be like 2 to 4 weeks. So the duration. So basically if you consider, if your sprint is only 2 weeks, and you will pick only whatever you can do in those 2 weeks. And then how do we pick it? We use 80-20 rule. 80-20 rule is nothing but we try to pick whatever we can deliver faster in a much lesser time, but delivers much greater value. It is something like shortest weighted job, but it is something that is simple. Like it is 80-20 rule. Basically we pick based on the 80-20 rule, and then we actually send it to daily Scrum. What is daily Scrum? Daily Scrum is like our Scrum meetings, they call, because we are using Scrum framework, and we actually interact every day morning, and then that interaction, if it works and everything is fine, we deliver it. And then after delivery, and Waterfall ends here. If you look closely, Waterfall ends here. But in Agile, we'll have actually review. We do a sprint review, and then we actually do a sprint retrospective. Sprint review is nothing but what and all we have done, what are all going fine. It's like a basic review meeting. And once that is done, once everything is done, after release, this is before release, like after release, we do a sprint retrospective. Like what did we do? Like did we do any problems? How can we recover, or how can we improve? And what are all the things we can carry forward? Like what the best we did now, and how can we carry forward to the next level? So I think this is actually Scrum in a nutshell. So this is the complete Scrum. And here, like suppose you are the one, you have joined in a new Scrum team. Yeah, Naresh, someone has raised a hand. Yeah, Naresh Reddy raised a hand. Is there any question, or can I?
Sir, you can continue, sir. Actually, the questions will be posted in the chat box, so you can continue, sir.
All right. Yeah. So yeah, if you look at the Scrum team, basically, suppose if you're passed out of the college, then you might have joined something here. So then this is what I'm saying. I'm talking about like the team, Scrum team, and once that is done, then they got the requirements. They got the requirements from the client, and then they take all that and they go to the sprint planning meeting. Sprint planning meeting is like, so everyone will be like sitting here, and he's a Scrum master who is actually taking care of the sprint planning meeting, and he is actually taking care of all the meetings and everything. And once after the discussion in the sprint planning, they actually pick something. As I said, in the sprint planning, like they pick something, and out of everything they pick something. So that's what is happening here after the discussion. Once that is done, they go to daily meetings. In daily meetings, you will have a board like this. Like this is called a Scrum Board. In every day, in stand-up meeting, they will ask what to do for today, and what is going on, and what are the things which are working on, and what are completed for that particular sprint, for that particular 2 weeks. So when someone is actually completed, if you're something like the yellow page belongs to you, so you have 2 things in pipeline, and you are working on 2 things, and you have completed 2 things. And once you are done, you just move. Once you are completed, you just move from here to here. And this is like a drag and drop tool. You will use multiple tools for implementing it. So this is what the board, what you are seeing here, like to do, the board is that one. And once that is used in your daily meetings every day, so that you will have a lot of transparency. No one will ask you, but everyone will get to know what you're doing. So it is something like, in traditional waterfall, there won't be anything like that. No one is actually knows, until except your project manager. No one really knows what you're working on. But in Agile, everyone knows what you're working on, because everyone can look at the Scrum Board. So everyone can, and if you're completed, no one will assign the task to you. You can directly go and pick from the to-do board, because your to-do board is already it's already filled. And who will fill this to-do board? Your Scrum Master will fill this, and your product owner as well. But and then once you are done with this, then you'll go and you'll work on that particular day. You'll work for that, and once that is done, you will deliver the solutions. And this is the sprint review. If you look closely in sprint review, all the team are discussing, not the Scrum Master. He's actually an observer. He actually only help if there is something problem or something. So then you will get into a sprint retrospective. Once everything is done, you got everything, and you repeat the same process again in the next sprint. And before that, you actually check how we have done. That is retrospective, how we have done the past sprint and what can we improve. So basically, so that's basically the Scrum basically. So then we have done the Scrum, and we understand what is Agile, we understand what is Waterfall, and we understand why we are doing all those. Then things has become a bit faster. People actually they want to do it in a much faster pace, and they want to actually, if you look closely in the previous teams, there is a development team, there is a BA team, there is a DBA team, there is a tester team. But if you look here, BA team, architect team, development team, QA team, there is an operations team and architect team. They too are left out, right? Because they mixed these 3 in an initial Agile process. And once that is done, they want to send it to production. If they want to send it to production, they want to send it to, so they have done the coding, they are doing the planning, they are doing the testing, and then build, and again they're repeating this process in the sprints. Once that is done, I'm just saying it is going to release. But once you are doing the release, someone has to deploy that in production, and once the code is deployed, someone has to check whether it is working fine. Someone has to do that. This is called operations. Once that is done, once that is deployed, someone has to monitor whether the code is working fine on a day-to-day basis. So basically, there is here, if you look closely, the major 2 things here. One guy wants to actually do the development, and he wants to do the change constantly, and the other guy wants to make the system stable. He doesn't want any change, because he wants the system to be stable. If you change anything, it may break the code, it may fail, your code may not work. So these are the basic conflicts between the development team and operations team. That is when the DevOps actually come up. The DevOps is nothing but it's a mix of the development team and the operations team, and they want to mix both. It is something like they want development team, and then they do the build. Build is nothing but a compile kind of thing. Once they do the compile and they want to test it, And once the testing is done, then they want to deploy. Deploy is nothing but they have to put the code in the production so that everyone can use. And then they want to put it in the run so that, once the deploy is done, there's nothing but operations. So as we have seen, instead of doing 3 months, we have come up everything to 2 weeks. So if you look closely, our production activities has increased a lot, because we are actually touching production very frequently. So if you're touching production very frequently, you need to have some kind of automation. Automation is something like, then they have come up with a CI/CD. CI is nothing but continuous integration, and CD is nothing but continuous deployment. So it is nothing but the moment you have done the coding, and the moment you have done the commit is nothing but saving your code. The moment you saved your code, your build should start immediately, and your testing should be done automatically, and your build should be done automatically. So, and that complete automation is called continuous integration. And then it has to be deployed to the different environments. That particular thing is called a continuous deployment. So basically, in a nutshell, it's like CI/CD. So continuous integration and continuous deployment. So then they got into the process like the Devops, the evolution of Agile. So in that they mixed as I said, the cross-functional team. So they have added the cross-functional team from the build, code, plan, release, and everything to even they started, adding operations team member as well to the cross-functional team, and has become like a deployment operation monitor is also part of a cross-functional team. So basically, this is how the team structure. Like earlier, it was like development, it was QA, then it was operations. But if you look at this is what the DevOps is, who does everything. Like a development, QA, operations, that is when who does everything is called DevOps. So operation team, quality assurance, development, they picked one from every team and they made a cross-functional team here. So if you look at each cross-functional team, they will have a team members from everything. Like if you can look at the colors, like red is from operations, amber is from quality assurance, and blue is from development. So that's the software development evolution. So we have evolved from Waterfall, like doing from 3 months. Then we have evolved from 3 months to 2 weeks. Then we have evolved to DevOps. So, and if you look at closely, even if you look at like a Google or Netflix or like the big Facebook, did you ever see any downtime? They don't even you don't even see Google was down for even 1 hour, half an hour. Did you ever see that? We will never see Google was down, but you might be seeing like some bank sites are down, some ATM machine is down. You might be seeing some kind of a downtime for them, because because they actually stop everything and then they do the deployment and everything. Then only they'll bring the system up. But Google, Netflix, and all, they do the DevOps process. They deploy every second, every minute. You will be amazed like how many deployments there is going on. Even the session when we have started, they will, like hundreds of deployments would have happened by now, because everything is automated. Everything is automated. Whatever you do, like right from code commit to deployment, they have the complete automation process, and they're doing it so stable. And so that is why you're getting this thing like deployment, operations. So basically, as I mentioned, like when we're doing like the base, this one we have talked, like we have product stage, we have backlog. Backlog is nothing but a list of items, and then we have 2 weeks time, then we get a final product, and we take user inputs, and then we actually do it. Then we take a continuous feedback. Like once the first sprint is done, we take the feedback of that, and we actually do the second sprint. But now we are in a DevOps, Agile DevOps process. It is something like daily Scrum. Once the phase starts, daily Scrum, then sprint review retrospectives, then we do continuous integration. Because if you look at our old Agile model, our sprint retrospective is the end of the sprint. But here it is continuous integration. We are integrating continuously, and we are doing continuous testing, and then we are doing continuous delivery. So these three parts has added after getting into DevOps process. And you need to understand one thing. DevOps is not something different from Agile. DevOps is an evolution of Agile, but Waterfall and Agile are different. Waterfall is a different methodology. Agile is a different methodology. And the DevOps is evolution of Agile. So the process of cross-functional teams has evolved so that they involved all the development, operations, QA, everyone into one team. And even the future, they're actually involving like securities and cloud. So you are getting like a cloud security DevSecOps. You're going to, so that is the trend now, like a cloud DevSecOps. So then they're going to get it and they're going to go to the development. And once development is done, then they'll put it in a code repository. Yeah, I just don't want to get into much details, but I'll just tell you in a high level what is code repository. Code repository is nothing but the place where you will save your code. Because if you're writing a hello world program, you cannot save it in your local folder. So because everyone cannot see your code. So that's code repository is a place where everyone can see it. And then it's a server, like the continuous integration server. There will be some server where once you have saved your code, the continuous integration server, something like Jenkins, that is a tool that will actually picks it up and it actually puts up in the repository manager. Repository manager is nothing but once you do the compile, you'll get a binaries. So you'll get a compiled version, right? Java files or something, if you're doing a Java program. So then you get a var, jar and everything. Once you do the build, those files will be saved in the repositories, and then you actually basically checks the code quality and everything, like automatically code quality checks and everything. So that is basically comes under continuous integration. And if you move to continuous testing, so once you have done everything, and it's in simple terms, your development is done and you are automatically creating your compile. You are compiling automatically in simple terms. So once you're compiling automatically, and why do you think like we need such a big system to compile automatically? Because in real time, you will not have just a hello world program, because it's going to be massive systems. So every system, like thousands of programmers might have written already, and you are just going to write one simple program, or you are going to touch some modules. You're not going to do everything from scratch. Very rarely you do everything from scratch. So you need to have some kind of a version control tool to manage your code and everything. So that is why you have such a architecture, so that they can actually manage easily. And then they move that to continuous testing. Continuous testing is nothing but in the manual testing, like testing everything manually has gone. Those days are gone. Now we are moving everything to continuous testing. Like everything has to be automated. Like your test scripts will be automated, and your test suite will be automated. Automated is like even now they do the manual, but they add that to the automation part, so that the industry actually getting into the concepts like a TDD, BDD. BDD is nothing but behavior driven development. So I think these are high level concepts you learn one by one. And so in here they do that, then they put it in UAT, QA, like these are different environments, like where they put the code, and then they get into continuous delivery. Continuous delivery is something like here, simple terms, here you got a requirement. You want, someone asked you to write hello world here, and you have written your hello world here, and you have actually compiled it, and you saved it in some place called repository manager. That's called your repo. So then your Agile and that's called Artifactory basically. And the Artifact is not here, but Artifactory. So then that one is actually taking here, and you have tested your compile, you have tested your hello world program here. So they asked you to write hello world, you have written hello world, and you have tested, and you have compiled. And once you have compiled, you are testing here, and once you are testing it, you are actually deploying it into production. So that's how the basic Agile DevOps. Then how do we achieve? Because as I'm talking, everything is continuous and everything is going to be automated. But who is going to do that? How are we going to do it? Is it going to be magic? No, someone has to do it. So if you want to do all this, that looks so massive. And if you want to do the requirements, if you want to do all this automation and everything, we cannot do everything in 2 weeks, because it takes a lot of time. So that's why we actually leverage the tools of DevOps. Leveraging the tools of DevOps is nothing but we actually for every phase, there are some standard tools in the market. So we actually pick one tool from it and we started using it. Like for planning, we use Jira. And for code base, we use Git. And for building, like building is nothing but compile, we use Gradle or Maven. And for testing, we use Selenium or JUnit. And for this is the continuous integration. I was showing like CA server. So for integration, we use like a Jenkins, Bamboo, or a Travis CA. So mostly like Jenkins is popular. So JUnit and Selenium are popular, and Gradle and Maven are popular. Git popular. So if you want to learn, you need to learn all these. Like then for deployment, you can use like these 4 are for configuration management. So if you're trying to deploy the code, and mostly the Ansible is popular now. So if you want to learn, you need to learn Ansible, you need to learn Jenkins, you need to learn JUnit and Selenium. And don't worry, like you may think these are 10 or 15, 20, 100 things, but it will be something like your Android mobile app. How you are using your Android app and how you are using some 10 applications in your mobile. And if you're using chat, WhatsApp for chat, Facebook for that, and if you're for Spotify for you listening music. So similar way, these are some 10 or 15 apps that you're going to use on your mobile. That's it. These are not complex, but just you need to understand what is doing what, and you need to start getting familiar with it. Then to monitor your applications, they use like a Nagios. So overall on a high level, that's what the DevOps tools. Then if you look at the virtualization, and if you look at the how the process is, so they have started from a non-virtualized hardware initially in 2000. Then the virtualization has come up. Virtualization is nothing but on a physical mission. They started actually dividing that mission into multiple parts. They call it as like by installing virtual missions. So then it's like infrastructure as a code, infrastructure as a service, platform as a service, open source, containers, cloud native. So these are like the evolution of the software as well. How we actually evolved from hardware to cloud. So it is simple, like it is nothing but you are having a mission. So you are having a mission like your mission, and then we got virtual missions so that you can actually scale up and scale down. It is nothing but you have your mission like a 4 GB RAM and 8 GB your personal computer. If you want to make that computer into 2 computers, you need to actually install virtual missions. So they actually come up like 2 virtual missions, and then you can ignore all these, like because everything is almost similar. Then you can get into containers. Containers is nothing but after the virtual missions, the major breakthrough is container. Because in container is nothing but it's kind of a simple OS. Instead of breaking your system into 2 different systems, you can use one system and you can actually use multiple containers on a single OS. Because virtual mission needs, if you have 10 virtual missions, you need 10 OS. But if you have only one mission, you can use multiple containers. So and container is like a lightweight product. And then they got from data centers, they don't want all the containers and everything. They don't want to store in your data center. They want to put everything in the cloud. Cloud is nothing but you can access anywhere, and your mission is on cloud. And your physical mission where you are actually working, it doesn't process using that mission. Your processing, everything will be done using cloud. And you guys are already using cloud. Maybe you know it or not. The Google, the Gmail, what you're using is on cloud. The Facebook, whatever you're using is on cloud, because whatever you run and everything, the request will go there and come up. The web, whatever is, so all those things are applications. And what happened was, basically why we are actually getting into DevOps is, it's not only the continuous integration and continuous deployments. And then when you are actually evolving, and you are using a Flipkart, for example, and your Flipkart is actually growing every day. And once you are actually growing, your Flipkart is growing every day, and you are starting getting requests, and your Flipkart has become so popular, and billions of people started using it. When more people are started using it, your system will get a lot of burden. Like your system can handle only 100 requests, but you started getting some 150, 200. You cannot handle with the same mission, right? You need to have multiple missions. or you need to have a different way to handle that. So that is, so they want to increase the mission size from 4 GB to 8 GB, from 8 GB to 16 GB. They started increasing it initial days. So that is called vertical scaling. They were actually handling with this mission, but again they got a more load, they went to bigger mission. They got a more load, they went to bigger mission, but they started getting more problems because vertical scaling is so expensive. They can't actually, because of hardware problems as well. Even if you look at you might be seeing the similar issue even with the TVs and everything. You might be seeing some 32 inches, 40 inches, they are all so cheap. But if you go to like a 80 inches, suddenly the price will become 4 or 5 times. Though the inch is only 1 or 2 times, but the price becomes so high because the more popular it is, the more demand, as I said, the demand and supply, the more demand it has, the more cheaper it will be. So it's because on the scale of massive scale, I'm just talking about on the scale of massive when you're a consumer. So they got a horizontal scaling. When they got a horizontal scaling, like if you're actually doing it on your physical missions and suddenly on one day, if you're getting a load of 100 and next day you're getting only 20, and the simple things like in 1 month, you will get load only for 2 days and remaining 28 days, you don't get any load. And can we do this horizontal scaling on that? Like only one day, can you get some 30 missions and again next day, can you remove all the missions physically? No, it's not possible because we can't buy for only 2 days and we can't sell and we can't buy again. It's a lot of hectic process. So that is the reason we got into containers. That is the reason we got into cloud. Because in cloud, you can spin up, and spin up is nothing but you can start missions automatically and you can stop missions instantaneously. Like if you want to start some 10 missions now, you can start it. And if you want to stop 9 after 2 days, you can stop it. And you can just pay based on use. Whatever, like if you use 10 missions, you pay that. And if you use only 1 mission, you pay that. So if you look at our 30 days, and if you're using only 2 days, and you pay only for 2 days, and if you're not paying for the remaining 28 days, it's so profitable for you. If you are actually starting a business or startup or anything, going to cloud is much cheaper and better option for you. So as I mentioned, this is what the hardware revolution has started. Like it's a dedicated server, and from dedicated servers they went to virtual missions. And from virtual missions they went to containerization, and from there they went to serverless. Serverless, as I said. So here, if you look at it, so there will be different. This is your server. Then you have 2 different virtual missions. But if you look at containerization, you will have a container engine, and you can have 2 applications running on the same virtual mission. On the same mission, you can run 2 applications. But here, if you want to run 2 applications, you need to have 2 missions. So that's the beauty of container. Container is nothing but it's a kind of a mini OS. So, but if you look at serverless, it doesn't need actually anything. It doesn't need any missions. It can directly run on the cloud. That's what serverless. You don't need any mission. You can just write the code and the cloud, it start running it. So on a high level, so this is what the virtual mission and containers. Like the basic difference is, I'll just explain the basic architecture. The physical server, then you will have, if you look at the virtual machine, it will have like a hypervisor, a layer called hypervisor that actually enables your virtual machine. And inside your virtual machine, you will have a OS, guest OS. But if you look at your containers, you will have a physical machine. On that, you will have only one operating system. You will not have multiple operating. If you look at here, you will have multiple operating system. But here you have only one operating system. But on top of that, you will have a Docker engine. Docker engine is nothing but a container engine. Docker is one of the containers, popular container right now. So you will have the Docker engine. On Docker that, you will have your container 1, container 2, container 3. So that's how we actually our physical hardware has evolved. Now, if you look closely, I have talked about the software methodology evolution, hardware evolution, but if you look at our practical applications, we have so big applications. And how can we actually container is, as I said, container is very small, and it is actually mini voice. It's not a big voice. So how can we handle that? That's where we got into microservices. Microservices is nothing but, so look closely what I'm saying. You have initially you have divided the time from 3 months to 2 weeks. That is from Waterfall to Agile. And again, from 2 weeks, we have automated everything. That is, we moved from Agile to Scrum to Devops. And now, then we actually divided hardware, and we actually divided hardware to data centers. Like, if you divide the hardware to dedicated servers, to virtualization, to containers, to serverless. So if you look closely, everything we're splitting into small parts. Then we are trying to, from there, we are actually trying to split even the application what we have into even smaller parts. So earlier, the logic used to be like user interface, business logic, data interface, and one database. But now what we do is like we divide everything into small parts. That is called microservices. So like if you're using Flipkart, and if you're using add to cart function, so we write only add to cart function in one microservice, and we write the billing logic in one function. I'm just explaining. It's just for sake of for your understanding, so that they can actually access and they can be much easier to maintain. And if you're joining a team in this architecture, you need to understand entire business logic if you are trying to make even a small change. And as I said, like Google is doing like thousands of deployments even per day. If they're doing so many deployments, they cannot touch entire business logic every day. It is so complex and it is so dangerous. That is why they have split everything into microservices, and they started actually changes only small things, so that even if something failure is there, only that particular microservice has to be backed out, not everything. That's the beauty of microservices. So on a simple terms, so on a high level, this is what the basic architecture of Facebook. Like if you're using high level, don't get worried about the big diagram, and I'm not going to explain each and everything in that. So just for understanding, like if you're a user and if you're on a web browser, if you hit, it will convert your facebook.com will convert into IP address, and the load balancer will send to corresponding VMs, and you will have web server where your web application will be hosted, and you will have an application server where your business logic will be hosted. And the server is nothing but a computer where you actually run your Hello World program. If you're running Hello World program on your mission, and it's just your personal computer, and if you're running it on a data center or something, that is they call it as server. On simple terms, that's it. Server is nothing big. It's something like your basic computer just running the program there. And if you have a web application, they call it as a web server. And if you have a general business logic, they call it as the application server. And if you have a database, they call it as a database. And to write and to get the data and fetch everything, they use the database cache and everything. And ignore about all this. And generally, this is what high level. And if you have this, and if you don't want data center, you want to move to cloud, because as we are talking about virtualization, and from there we are actually talking about containers. And then from where, as if you want containers, what is the use of containers? You want to spin it up automatically, you want to spin it down automatically, right? So then we move to, that's the cloud. The same thing, if you do the same thing in cloud, that's the cloud. So if you look, the DNS, your DNS in cloud is nothing but Route 53 in AWS. I'm just talking in AWS. If you're doing the same thing, the load balancer is nothing but elastic load balancer in cloud. So if you're doing virtual missions, your virtual mission is nothing but EC2 in cloud. And your web server is nothing but EC2. EC2 is nothing but it's basically a server where you can actually deploy everything. So if you look closely, cloud is nothing but doing the same thing, but in the cloud, using the cloud applications. Is there any change? Absolutely no change, except the names. So what's the names? You are just using the cloud application. So don't get worried that if you're using cloud, it's something new or it's something really different. It's not different. It's the same thing with the different names. And then on high level, like as I mentioned, DevOps, like now we know about the cloud, and we know about the containers, we know about the microservices, we know about everything. And now on a high level, this is what, like you actually take the Git and you do the checkout and build, and then you actually do the unit testing. How do you build? You build using the Maven and Gradle or anything. And one more thing, if you have multiple tools, you can just pick one. Don't worry, like you don't need to pick everything. You can pick only one. Pick Git from for checkout, and pick Maven for build, then do the unit testing. And then unit testing, you have tools, but they did not mention there. But the quality control, you can pick. The quality control is nothing but checking the coding standards and everything. You can use SonarQube. And from SonarQube, you can do the deployment to the test server. And then once the fetch, then you can do integration testing with Selenium. It's basically same thing, but I just kept it again because so that you can do the deployment here. You can do the deployment environments, VMs, cloud, bare metals, anything. So what I'm trying to show is you can do the same thing and finally you deploy it on the cloud or mission or wherever, whatever it is. It doesn't matter. The process is going to be same. The automation is going to be same. The integration is going to be same, and you're going to do the same DevOps process. Now coming back to now mixing the Agile with the DevOps. As I mentioned, if you look closely, this is the complete architecture. This is the complete architecture of the organization. So the complete SAFe is nothing but scaled Agile framework. They have given a framework for the complete organization, and don't get worried, you will be somewhere here. Like this is a DevOps process, and you will be somewhere here in the Kanban boards, and you are here. So if you look at the Agile teams, you will join somewhere here. So don't worry, you don't need to do everything. You'll be somewhere part of here, and you'll be interacting with your Scrum Master, and you'll be interacting with your product owner. So this is the basic Scrum Master. And if you look, like if you draw a straight line here, and this is what you do. Like you work on the team backlogs, and then you do the Scrum, and then you do the continuous integration, continuous deployment, continuous delivery. Then you work on the sprints. They call it as a program increment. It's because we are actually doing increments. This is the spirals. We have like spirals, right? We have. So yeah. So that's it. So then we go to the deployments, and overall that's what it is. And then now coming back to things to know to become a DevOps engineer. If you want to become a DevOps engineer, basically you need to know programming, and then you need to know system administration, because as I said, it's a cross-functional team. Everyone should know everything. So mostly they expect you to know system administration, then cloud management, then on containers and orchestration. So if you want to handle multiple containers in cloud, that will be handled by the Kubernetes. So if you want to spin up like thousands of containers, and if you want to shut down, all those containers will be handled, all the auto scaling and everything will be done by Kubernetes. So overall, that's what it is. And don't get overwhelmed with all the details of the administration, programming, and everything. And slowly, you can learn and pick it up, because no one will expect you to know everything. But I just want to give you and show you the path, and whatever the technology you are going to use, it's not a DevOps engineer. Whatever you are going to use, like you're going to use it. And then the implementation and growth scope. The implementation is so this is something like how many people has implemented DevOps so far. So if you look closely, only very few people has implemented DevOps so far. So I just want to show you there is a huge growth scope. Even if you get in now, there is a huge growth for you, because everyone is trying to move to DevOps and cloud. And whatever, even if you're a full stack developer or backend developer or front end developer or machine learning engineer, artificial intelligence engineer, whatever it is, you have to use DevOps, because everyone is moving. And that's important roles. What they're looking right now, they're looking at a full stack developer, backend developer, data scientist, front end developer, DevOps engineer, and QA engineer. And if you look closely, these are the primary roles in any organization, like full stack and backend developer, because every organization bread and butter will run by these. And if you look at data scientist, it's like a data scientist, front end developer, DevOps engineer. These are add-ons, not add-ons. These are required. Like out of 100, if they have like 60 roles of these, but they will have only 40 roles of this one. So that is the reason you look at a small percentage. But remember, guys, if you're getting into bigger percentage areas, you'll have a lot of competition, and you need to compete with so many people. If you're getting into minor areas, you'll have lesser competition, and you need to compete with a less number of people. This is one way of looking at it. And if you want to, what language do you want to plan on learning? Like if you want to look at the complete, this is the 2020 statistics. So from Code Camp. So if you look at it, so Go is the most famous and most useful language. Why the Go is more useful? Because if you look at everything, I'm talking about scaling a lot, because the Agile mindset is nothing but moving fast. we need to move quicker. When we are moving quicker, we got into actually Scrum. Then we want to move even quicker. Then we got into DevOps. We want to move even quicker. Then we got into containers, orchestration of using DevOps. Then we want to get into even quicker. So we are getting into serverless. So these kind of scaling will be supported by Go and even Python. Python has a lot of support. So these are the programming languages which you need to focus. So if you are focusing on the like a top 6, Scala has very good demand right now. R has a good demand. But if you are focusing on Python, Python is easy to learn. So if you want to get into hotcake and also easy to learn, get into Python. And if you're good with programming, then get into Scala and Go. Then coming back to the interview prep. So the interview preparation is something like I have given the links, and you need to basically prepare algorithms, system design, and practice HackerRank or LeetCode platforms, and read books like Cracking Coding Interview, and leverage YouTube channels like use like I have given 3 YouTube channels which are good, really good. So and practice some sample GitHub projects, and be with a good resume and with a good LinkedIn profile and a Glassdoor interviews. So if you click on this one, algorithms. So she is the author of Cracking the Coding Interview. There is a big playlist where I have given. You can read everything like a dynamic programming, big Go notation, all the things. And she's a highly rated lady, and moreover that if you follow all these, you can actually crack Google, Microsoft. You can get into high paid jobs. You can get into like even other than TCS, Infosys, you can get into very high paid jobs if you actually practice all this. Even if you can't get in as a fresher, you can get in with like experience, like 2 or 3 plus experience. You can get in with a very, very high paid jobs with high paid skills. And be familiar with this system design. I think that's not working. I will actually update it and I will send it. So then HackerRank, be familiar with the HackerRank. If you actually look at this has become a standard now. So be familiar with the HackerRanks because they are actually hiring, they are actually supporting by many people, and you can practice a lot of algorithms and everything there. And this is the book I was talking about. The book is Cracking the Coding Interview, and she's if you want to crack this book contains how to crack Microsoft interview, how to crack Google interview, how to crack Yahoo interview. So they will have all those, and get into like a YouTube channels. Like this guy is called Mosh. So this guy is actually really very good, and you can actually follow this programming with Mosh. Follow this channel. This is really good, very, very easy to learn. And even Telesco and Gaurav is similar, and this Gaurav actually covers a lot of system design topics. So this guy covers a lot of Java topics. This guy covers Python and front end. So I have even the 3 channels I have covered, like system design and Java and front end and back end. And yeah, resume and all. If you want any reference or something, you can just send me an email. I can actually send you some references, and you can actually have a look at my LinkedIn profile if you want any reference. And you can actually go through Glassdoor interviews before attending any interview. So then getting into overseas opportunities, like if you do a MS is the best option to get a job overseas. Otherwise, even because I did not do any MS, I have directly come from India. So it all depends. Like if you're getting good opportunity, you can directly come from there. But if you want to really get in easily, then MS is really good option. And salaries in US will high comparing with all over the world. But US has a lot of visa options, visa issues. So, and then you can actually look at Europe. And if you look at Europe, like Ireland has only 1 year MS, that's actually good option. And US has 2 years, and your cost of living and everything will, because if you're only 1 year, your expenses will come down, and you can actually stay for longer term in Ireland if you want. And you can use these calculators, like if you want to convert, like if you want to check what is 1 lakh in Europe, if you are getting 1 lakh salary in India, and how much you have to get in Europe. So you can, to match the same standard of living, I have given a few calculators. So you can use that. And if you are actually trying to go to any country, use this cost of living calculator, so that you can check from here itself, like to do all the calculations. Yeah, that's it. I think I'm left with another 15 minutes for Q&A. Thank you so much. Thank you.
Yes, sir. All the participants are requested to fill the feedback form, which is posted in the chat box for getting e-certificate. And if any participant is having any sort of doubt, they can raise it through the chat box. Sir, you can see through the chat window, sir. Bala, sir.
Yeah, I think Ravi has asked a question like in crisis, what should we do?
Balu,
And he mentioned even in
can you advise them what are all different universities available in Ireland and specializations available and what technology is popular in Ireland? So
yeah, there are the Dublin University is actually more popular, and there is a college called Trinity. You might have heard Trinity is very good college, but the Trinity London is actually basically very famous, and even the same Trinity college is there in Dublin. So where our Ramanujam and all those guys have studied, those guys have studied in London, like Sir C.V. Ramanujan. So the similar college is there in Dublin, and they can also there are also colleges in Limerick. There is also colleges in Galway. So few of my friends they are actually in Galway, and few of my friends are studied in Limerick. So few of them are in Dublin. So Ireland is a really good place if you want to go for a MS and if you want to settle for longer term. And really nice people, very nice people. So and very good work culture as well. I really because I'm here from almost 4 years, so it's more than 4 years basically. So I honestly suggest like Ireland is really very good place to do that MS.
For ECE students, what platform you advise?
So for ECE students, actually they can actually get into, because I'm also from ECE, so they can also get into IT, and IT has more options. But if they want to get into core like embedded, even embedded has good, but I don't see many options for embedded in Ireland basically, because the number of jobs in Ireland is big, and even for MBA or business students, there are no much options in Ireland. I mean, whatever I have seen, and in general, I'm just talking in terms of numbers.
Not only in Ireland, in European countries, which platform is preferred for the students to reach?
Yeah, that's what, sir. I mean, I'm just talking about stats. Stats is like if you look at stats, like getting into IT is the best option, because right now IT is in a really big boom. So for ECE students, I mean, they can actually get into even embedded, but I really suggest if they really get into, if really they want to get into MS or overseas, then getting into IT.
And what about this AI and ML? Will it take much time to grow, or otherwise is it readily available in the market for what is that opportunity?
The next AML is going to be the future. AML has huge opportunities, and it is going to be the complete the next 10 or 15 or 20 years. The AML are going to lead, and if they want to get into a really good or a bigger opportunities, they have to get into even MS. Like they have to get for AI and all. They have to get into after a bachelor's. They have to get into MS. That's actually even good.
My question is, if everyone is looking into AI and data science, ML, all these, really number of openings are there in the market for those people?
No, sir. Actually, okay. The number of openings are not so much, because if you actually look at my if you actually look at this, the number of openings for the data scientist, actually most of the AI, ML and all, they come under this data scientist category. If you look at this, their category is actually only 10% or somewhere around out of the openings. But if you look at 43% and 20%, they come under full stack. So the number of openings will be less, and moreover the competition is actually very high, because all the IITs, NITs, all the Stanford, Harvard, most of the people are getting into AI and ML.
So now what platform you advise for third years and final years? For now, next they're going to final year. and finalists who are now going out of this campus as a graduate. So what is that exact platform you advise them to grow and reach success
They can
easily?
They can actually pick full stack development is really good.
Yeah.
Data scientist.
My question is common for all the branches of engineering, not only for ECMS.
Yes, sir. Yes, sir. I'm just saying general, like because I'm just talking about the 2020 stats.
Yeah.
So AML is really good. Data scientists they're going to be a future, and even full stack are good. Devops is good. They can actually get into these three basically. If on a high level, they can get into full stack, DevOps, blockchain, and AI or ML. Because those are not right, because
so one question is from CSE. So what about CSE students? So will you advise any special what is that technology advice to computer science students in this area?
Yeah, I mean, yeah, I would like to tell one thing for CSE or even EC guys as well. Most of the times we are actually more focused on programming like Java or Python or anything, but we don't actually look into networking and we don't look into system design. They should have actually networking, system design, and programming, all the three. This is the new trend which is coming up right now, because when I was passed out, if I know only programming, that's enough. No one was actually asking about networking. No one was actually asking about system design interviews. But actually, it is actually changing a lot now. As I said, everything is becoming cross-functional teams. So everyone is looking to know, even they need to know Linux administration. They need to know networking. They don't need to be expert, but they have to be familiar with all those. They have to be good at it. That is the reason actually I have given one link. Like if I'm going to share this link.
So one question is from one participant: in this crisis situation, number of jobs are less and competition is high. Can normal student get job easily, or will they face problems?
Yes, sir. Actually, that's the reason actually why I have come up with this slide. That's the first slide of my presentation, because I was also part of that crisis. And initially, for every crisis, there will be the pain initially, but they have to be persistent, and they have to actually be patient, and everything will be normal, because the markets are coming up and everything is going to normal. And but only thing is, they have to work hard, and they have to focus on the thing, and definitely everything is going to be normal, and everyone is going to get a really good life. Hello.
Yeah, Balu.
Yes, sir.
Anything you want to say?
Yeah, someone is asking about how about CSE students.
Yeah, CSE.
Yeah, CSE is, I mean, the presentation whatever I have given is like a generic template. It's for everyone basically. So, and CSE as well, I only thing I just want to mention is be familiar with system design, be familiar with networking, be familiar with I'm stressing, be familiar with algorithms, and be familiar with things. The basic set, that is going to be the basic set right now. Yes, sir. I think
yeah, almost two questions also over. So thank you very much, Balu, for your valuable time.
Yeah.
You have given us very valuable information from Waterfall to Agile to Devops. So really, session was very impressive. Hope our students benefited lots and participants also benefited a lot with this. And we wish you good luck, and we wish you good future. And really, all the participants benefited a lot with your session. So from Department of ECE, and I felt that it is your responsibility to share all your valuable note to your students, junior students, along with the participants. So with this, Adi Shankara is thanking you a lot for your valuable session. So all the participants, thank you very much for your participation. You will receive your certificate tomorrow. And Adi Shankara is conducting all these webinars. Previously, we have conducted all the events with the faculty and external